The real world is not static. Change and seasonality are part of all landscapes and all environments. The previous versions of Mundus Vivus had static landscapes. At generation, a height map was generated from Perle noise and some erosion algorithm. Then, during the simulation, trees would grow, but afterwards the simulation would reach a steady state unless the player interfered through deforestation or pollution generation. The real world is ever-changing. There is no status quo, no steady state, but rather balance lies in repeating cycles and patterns. The latest update has focused on making the worlds more dynamic with time. Temperatures and lighting can now change over the course of a year. This enables the modeling of winter-summer cycles, which is a common feature of large parts of the world. Also, the visual looks of the landscape will be affected by the temperature over the year, even adding snow below the freezing point. And the vegetation models can change based on temperature, some of them having unique spring, autumn and winter versions. This is highly configurable, so we can also model landscapes closer to the equator, where the seasonal temperature variations are not as noticeable. Before going too in-depth, I want to summarize the topics I'll cover in this video. I want to start talking about the Köppen classification method of climate zones, which is something I use as a reference for my landscapes. Then I want to go more in depth about the new features I've implemented. I'll end with discussing possible paths forward and where to take the project. The different sections are timestamped for your convenience. A climate is a long-term pattern of factors like temperature, precipitation and humidity, and often correlates to biomes. There are multiple ways of empirically classifying climates. The most commonly used system is the Köppen classification system. It has its roots in the following question. Based on patterns in temperature and precipitation, what kind of vegetation might one expect to find in a certain location? In this system, the Earth can be divided into 5 main types, these being tropical, dry or arid, temperate, continental and polar. Let's visualize these areas along a temperature axis. First, tropical should have no month with average temperatures below 18 degrees. Temperate can be anywhere in this range, where at least one month must have its average temperatures below 18 degrees, but not below 0 degrees. This is quite a large span. Then continental could be something like this, where at least one month must be below 0 degrees. And finally, polar has all months below 10. The arid region can exist anywhere on the temperature span, where you could have cold or hot deserts. These 5 main groups correlate to the type and amount of vegetation to be found. For example, the difference between the temperate and continental zones are whether there are any months with average temperatures below 0 degrees or not. This is a clear divider for many plants that can or cannot survive frost. Each main type can be divided further based on seasonal precipitation and temperature variations. In total, 31 subtypes exist. Each subtype is specified by a combination of 2 or 3 characters. The first character indicates one of the 5 main types already talked about. The second character indicates how precipitation varies over the year. For example, F notes that precipitation has little variation over the year, meaning there is significant amount of rain both during summer and winter. These areas are typically heavily forested. The characters W and S denotes that there is a dry and wet season, and that dry season can be either on the winter for W or summer for S half of the year. The savanna biome is a typical example of this, where there are distinct dry and wet seasons. The lack of constant precipitation will typically give less forest coverage, and instead more seasonal grasses and shrubs. The third character indicates the temperature span. This allows for finer separation. In both North America and Northeastern Europe, this gives a clear latitudinal separation, where here DFA, DFB and DFC are all humid continental subtypes with different temperature spans. If we go back to the temperature axis we made before, we can subdivide the existing types by the third temperature letter. If we do this, the temperate and continental types could have ranges something like this, where X could be any of the precipitation patterns. Another representation is this, where each line is an example of the temperature variation for a specific subtype. If you're interested, I found 2 interactive maps for visualizing Köppen Geiger types of the world. This lets you click on countries and see their type distribution as a change over time. For example, where I live in Scandinavia, there used to only be continental and polar types, but during the years some areas in the south has changed to be temperate. Here's another tool that's not based on countries but rather spatial cells. So why have I talked about this? Well, this relates to some of the new features I've implemented. The newest version of Mundus Vivus, that being version 0.10, adds dynamic temperature variations. With varying temperatures, I can now model summer-winter cycles. This makes the world feel more alive and will enable more complex gameplay features going forward. Temperatures are modeled as a trigonometric function over the year, with a linear negative offset with elevation. In the real world, temperatures drops approximately 0.5 degrees for every 1,000 meters of elevation. Here is a time-lapse of the DFD Köppen subtype, also called extremely cold subarctic climate. This could model parts of Siberia, for example. The summer season is very short, which gameplay-wise would mean a short growing season and limited trade by ocean because of ice formations. Winters are long with very low temperatures. Vegetation-wise, it's mostly coniferous evergreens like spruces and pines, with a few hardy broadleaf trees like birches closer to the sea level. The light intensity and direction varies greatly between summer and winter. This is to model the tilting of the Earth and the varying number of sun hours that you get close to the poles. To contrast, here is a CFB Köppen subtype, also called temperate oceanic climate. This could model something like Western Europe. The winter is mild and short, and the temperatures never reach extremely low values, except briefly up in the hills and mountains. At sea level, broadleaf trees tend to dominate, with spruces and pines becoming more common at higher elevations. Gameplay-wise, this landscape would be easier with longer growing seasons and less harsh environments. The reason for talking about the Köppen climate classification is that I use it as a basis for configuring the simulation dynamics. I like the idea of connecting my simulation dynamics to something concrete and empirical, instead of making guesses and assumptions. I've not yet added dynamic precipitation cycles. I'll talk more about the reasons later. But with the varying temperature and then assuming a humid environment, I can roughly model 8 Köppen climate types, that being the tropical rainforest, the 3 temperature zones without dry seasons, and the 4 continental zones without dry seasons. I've ignored the arid and polar types because I don't think they fit into any gameplay yet. The user can choose one of these preset configurations when starting a new simulation session. This enables fast and easy configuration, and for people who are familiar with the Köppen types, they provide a clear indicator of what to expect in the simulation. You can modify most of the parameters used in the simulation to experiment with other scenarios and just stress test the system. I can't guarantee that all configurations will be, let's say, realistically viable, but you can try them out. Something the Köppen types don't capture perfectly is the degree of harshness or variability. If we compare northern Canada, northern Scandinavia and part of northeastern Russia, they're all classified as being subarctic or DFC. By them being in the same Köppen zone, we could imagine that they are very similar, but they are not. If we look at maps of temperature averages and ranges, we can see their differences. Let's pick 3 coordinates. The point in Scandinavia has an average temperature of roughly 0 degrees and a range of roughly 25 degrees. The point in Canada has an average temperature of around -10 degrees and a range of roughly 40 degrees. The point in Russia has an average temperature of around -20 and a range of 55. 55 being an extremely big range. They all fit into the same Köppen type, but they vary a lot. They vary in how mild or harsh they are. The mildness index is not something I have as part of my simulation setup right now, but it could be worth adding in the future. Another thing that changed with this version is the landscape texture interpolation. In previous versions, each hexagon had its own texture type that would blend smoothly between adjacent tiles. In this new version, the texture inside the hex is interpolated between multiple textures. This enables even smoother transitions. Visually, this looks much better and enables more kinds of landscape texturing in the future. As part of this, pollution will now impact how the texture is interpolated, giving more of a visual feedback when land is polluted. Most of the work for this version has been related to asset generation, mostly modeling the trees, finding good textures and combining them to something that looks okay-ish. The actual code implementation part has not taken that long. I reflected on this and think that going forward I should focus on what I'm good at, which is not the asset generation. I want to focus more on the simulation, gameplay features and optimizations. I want to outsource as much of asset generation as possible. I've looked for available tree models for sale, but they either look like cartoon toys or are ridiculously over-engineered. In order to have tens of thousands of trees, and possibly even up to 1 million with some optimizations, I need models that are simple, but that look good at a distance. If we look at the birch model I've made, it's very simple. Mesh-wise, there are just 266 vertices and 110 triangles. The texture is just 512 by 512. But in the simulation I still think they look good enough. I think a proper 3D artist could generate something much better and still keep the mesh and texture sizes low. If anyone is aware of these kinds of high quality yet low size models, please let me know. I'd gladly outsource this work. I'm a software engineer, not an artist. Now let's talk about the future. There are many things one could focus on. The biggest, I think, are this: lakes, rivers and precipitation patterns. This would allow the modeling of more Köppen types, like the Mediterranean climate, savannas and monsoon climates. In order to generate good lakes and rivers, I would need to implement this graph-based erosion paper. Having done that, I could set up an erosion and world generation pipeline. This would enable the mixing of multiple erosion algorithms to generate more complex landscapes. Could look similar to a shader graph with click and drag functionality for ease of use. On the gameplay side, population dynamics and cities would be interesting to model, especially now that there are winter seasons. Things like seasonal food generation and storage would then become interesting. The road system is pretty bare bones and could need an upgrade, both graphically and functionality-wise. Adding transportation over water is also needed in the long run. On the simulation side, LOD levels for the landscape and potentially the trees could enable bigger landscapes. The current landscape size is just something I tried initially, but with some optimizations, I think you could have landscapes that are 10 or 100 times the size, if wanted. Regarding optimizations, there is more work to be done on the tree graphics. Currently, there is a bit of a CPU bottleneck related to how I handle the transforms that I send with my draw calls. I believe more work could be offloaded to a compute shader. Something that would be relevant both for gameplay and the simulation are environmental events. Things like tsunamis, hurricanes, wildfires, monsoonal rains, dry spells, blizzards or volcanic eruptions. This would require a lot of new graphical effects to get right, and I do want to get it right. Because of this, I think it's a feature for further away in the future. I'm currently undecided on exactly what to work on next, but it's leaning towards population dynamics. Let me know if you have any other suggestions, either here in the comments or on the Discord server. The latest build is available for free on the itch.io page. Any feedback is appreciated. I love simulations, and I hope you do too. Thanks for watching.